Hello, and welcome to another episode of the Geotechnical Engineering Podcast. In this episode of the Geotechnical Engineering Podcast, I'll be talking with Dr. Kathryn Petek, a Senior Associate Geotechnical Engineer at Shannon Wilson Incorporated in Seattle, with nearly 20 years of experience in design, construction, and research. And today we'll be talking mostly about large diameter foundations. I'm your host, Jared Green, and this is the Geotechnical Engineering Podcast, a podcast focused on helping geotechnical engineers stay up to date with technical trends in the field. Before we get started here, this is a free show, and our sponsors help us to keep it free. And now I'd like to recognize our sponsor for today, Menard USA. Menard USA is a specialty ground improvement contractor that works nationally, providing design-build ground improvement solutions at sites of problematic soils. Menard works closely with civil, structural, and geotechnical engineers to minimize foundation costs for wide ranges of soil conditions, structure types, and loading conditions. To learn more about Menard Group USA or for your help on your next project, please visit www.menardgroupusa.com. That's www.menardgroupusa.com. With that, let's jump right into today's episode. Hello, and welcome to another episode of the Geotechnical Podcast.
Hello, Jared.
How are you doing?
I'm pretty good, and you?
Doing well. Well, Kathryn, I'm glad that you were able to come on the show. We gave an introduction to you, to our listeners, but in your own words, can you tell us a little bit more about your background as an engineer, and also what is it that you do at Shannon and Wilson?
Sure. So I'm a geotechnical engineer at Shannon Wilson in Seattle. We're a full service geotechnical and geoenvironmental engineering firm. About me specifically, I'm a Seattle native. Growing up as a kid, I was good in school and I liked math and science. My parents certainly encouraged me in those directions. I went to the University of Michigan, to the College of Engineering as an undergrad. And, honestly, I got there though, and I hated it.
Hate's a strong word. You hated
Well,
it?
I really disliked it, I would say. And I had these friends who, they're studying art and history and reading great books and debating politics and philosophy. And it just seemed like so much more fun than thermodynamics and mechanics of materials. And for a long time, I felt really uninspired in engineering school. I made my way to civil engineering, and thought I would focus on structural engineering. But then I took my first geotechnical engineering class, and I would say that my whole world changed.
Really? Wow.
In that, suddenly I had something, that was really exciting to me. I liked the geology aspects of it, working with natural materials. I loved that, every problem is unique. The site conditions are always unique, and there wasn't necessarily a single right answer, that problems could be approached from different directions, that there's always different factors to consider, and different solutions to problems. From there, I had my first geotechnical engineering internship, actually at Shannon Wilson, the firm I'm at now.
Okay.
And I spent a big part of that summer watching drilled shafts go in. These were 4-foot diameter drilled shafts back in 1999. We used to think those were big. And I was really excited about it from then on. And I went and got my master's degree at the University of Washington. And after that, I took a fellowship abroad at the Royal Institute of Technology in Stockholm, and there did some interesting work for a year on the topic of train-induced ground vibrations. It was a total departure from everything
Wow.
I'd done so far. But it was a really remarkable experience, and while I was there, I had the amazing opportunity of attending the Nobel Prize dinner. And the Nobel
How does
Prize is
that
given
happen?
out. Yeah, so it's given out every year in Sweden, and they have a lottery for all of the students in Sweden to win one of the lucky seats at the table. And I had a colleague who was a fellow American on the same fellowship I was, and she had thrown her name in the hat. And amazingly, she won. And she didn't know many people in Sweden at the time, and neither did I. And she invited me to be her date to this dinner and ball and gala.
Wow.
And it was the 100th anniversary of the Nobel Prize at the time. And so they invited back all the living former Nobel laureates
Oh my
for
goodness.
this event. And they, here we are at this dinner and ball, and we're two single young women who just attached to each other there, and all of these former Nobel Prize winners and some members of their teams and people from these various academies, and they're all men, for what that
Wow.
is. And here
Wow.
we were, and so I danced the night away, never having been to a ball before, with these brilliant people. And the party went on till like 5 in the morning. And I remember the last hours talking with the guy who got the prize in economics a few years earlier, and it was the most inspiring night of my life
Wow.
by far. Um, and then the next day, I got an email from my master's advisor,
Okay.
and he said, Kathryn, we got funding to continue your master's research. You want to come back for a PhD? And and after all that, I mean, it was impeccable timing. I said, yeah, sign me up, please.
Wow. Wow.
So I went on then, and I went to the back to the University of Washington, and got my doctorate. The project evolved somewhat, but it was on the topic of numerical modeling of deep foundations. We created a new three-dimensional interface element for soil structure interaction problems. And I think that research, it was actually really defining of my career and practice, in that it had this hugely numerical element to it. And then we had an implementation of it, and then we used it in some practical applications. And so
Okay.
I think that that's me. It's like, there's some advanced analytics in there, but certainly grounded in bringing it back to practical problems and solutions.
Wow.
So completed my graduate work in 2006, and then came on here to Shannon and Wilson full time after that. And since I've been at Shannon and Wilson, I've just had tremendous opportunities and have worked on a great number of projects, from, you know, landslides to big retaining wall projects to a lot of transportation infrastructure. I've developed some specialization in deep foundations, where I've had the opportunity to work on some great projects where we've done, extensive load test programs on large diameter drilled shafts and driven piles, base grouting. Here in the Pacific Northwest, we have significant seismic hazards. So a lot of soil structure interaction, liquefaction, and lateral spreading hazards. All of that tying into our, foundation recommendations. So lots of cool things.
That's awesome. That's awesome. And I think that you can see that timing is everything.
Yeah. Yeah, yeah.
Wow. So to go from being uninspired to being inspired to going all the way to that PhD, that's incredible. That's incredible.
Uh, yeah, thank you. Thank you. There's, yeah, been a lot of fun along the way for sure.
What would you say? What would you say to the student that's listening and they're uninspired right now and they're in an engineering curriculum? How do you turn it on? Because I can't tell if you turned it on or it just turned on. But what would you say to that student?
I mean, everybody, what inspires them is different. For me, I think I feared that my engineering career would just be, stuck behind a computer and behind a calculator. And and I like more than that. And really, I think our careers are, we do, project management, there's marketing and proposal writing. I think, communication is such a huge part of what we do. articulating our recommendations. I spend a lot of time writing, whether it's writing up, for proposals or recommendations, and all of those things, really play into, the other sides that, are a little bit softer than all of the analytical things we do. And I have a big brain. I like doing technical stuff, but I really
Yeah.
like the other things too. And I think that it's much more interactive and incredibly more creative than I assumed it was when I was, doing, statics problems.
Yeah.
As an engineering student. So,
Eh,
and I do think also, sorry to interrupt,
No, it's okay.
that there's certainly opportunities to build on one's strengths and to make it, what fits to you, right? I mean, this is still engineering,
Yeah.
but there's people who focus only on calculations, and there's people who step way farther beyond than that.
Yeah.
And I think that there's a lot more opportunities there than we may see.
Got it. Got it. And then the PhD, did you ever think that you'd go on to get your PhD? Let's say when you were, I don't know, a senior in college, did you ever think that you'd go on to get a PhD one day?
No,
Not at all.
no, I don't think so. I mean, no, but opportunities presented themselves, and it was a lot of fun and really
Yeah.
an interesting time, and I wouldn't trade it for the world.
That's awesome. That's awesome. Oh, glad to have you here. Really glad to have you here. I'm almost scared to ask this because it's probably not a typical work day, but what does a typical work day look like for you, Dr. Petek?
Well, yeah, you said it. There's really not a typical work day. We do many things. In my role now, I started at Shannon Wilson as a staff engineer, moved my way up to kind of mid-level, and now I'm a senior associate at Shannon and Wilson. And so this means I certainly lead projects. And so, there's interacting with clients, trying to work through issues, and then, things like scoping and budgeting and, project tracking of budgets and uh, time management where we're at. And there's overseeing staff that includes, executing the work, developing staff, and helping them to grow. As a in my firm, I have, recognized skills and deep foundations. And so, I regularly field calls saying, Kathryn, what do you think about this problem? Or can you lend some support on this project to provide some oversight? And those are really fun jobs to kind of step in and then step back out
Yeah.
again. Um, and project management, marketing, that's a big, we're always looking for the next project.
Yeah.
And so keeping an eye out, talking to people, working on proposals, and executing the work. I've also involved in some national committees, technical committees related to deep foundations, and so some committee work there, participating and attending conferences, and so on. So
Excellent.
yeah, there's a huge gamut. Every day is different. There's always new things.
Keeps it interesting, right?
Yeah.
Awesome. And then, during your internship, you hinted that, a 4-foot diameter was considered large at that time. What is a large diameter shaft? When you're thinking large diameter, what is a large diameter shaft these days?
Well, I mean, large is relative.
Yeah.
I've got some really interesting projects going on right now. You know, I've got 2 projects ongoing right now with 12-foot diameter
Wow.
shafts. I would say
Okay.
that those are pretty large.
Pretty
It
large.
used to be, 6 and 8 foot was large, and now large is pushing, the 10 and 12-foot diameter range.
Yeah.
In shafts, driven piles. I led this research project for Federal Highway Administration related with large diameter open end piles for those. And I think large is generally anything greater than 30 or 36 inches. And there's a
Okay.
whole different set of what's going on there. I also have another project of closed-end piles,
Hmm.
where right now we just have a project where we've been driving 36-inch diameter closed-end piles. And frankly, I'd never heard of
Wow.
anybody
Never
driving
heard of that.
anything larger than 24-inch closed-end.
Yeah.
But so, certainly we see things are getting bigger, loads are getting bigger, we have more demands, and, an upsizing all around in
Yeah.
foundation sizes.
Well, what kind of wall thickness are you looking at for a 36 diameter close-ended driven? I mean, that's got to be pretty robust section.
Well, now, Jared, you're going to push me on this. I think they
Uh-oh.
were 1-inch walls, but
Okay.
it may be 3/4 inch.
Okay. Got it. Wow, that's
So they
wild.
were they were driven 120 to 140 feet deep. And
Okay.
so there was certainly some interesting challenges there.
Yeah.
They're going in fine grain deposits, kind of somewhere in the range of 20 to 40 blow count material.
Okay.
And, they're really, in other solutions, we weren't getting really enough resistance.
Okay.
The closed-end piles tie in to form like a soldier pile abutment wall
Mhm.
there. But with getting these to tip, we had a lot of uncertainty, with how can we get them down? How big of
Yeah.
a pile will it require? Can we really get the capacity that we needed? So we spent, a lot of time on the weep analysis,
Mhm.
and the contractor came out with a smaller hammer than we recommended, and
Okay.
they got them in the ground,
Wow. Okay.
and the dynamic testing proved out nearly perfectly. And so it was quite a success and a really interesting application
Okay.
for us. Yeah.
That's great. That's great. Well, I'd love for you to talk a little bit more about the FHWA research project. So I understand you were the principal investigator there, and these are large diameter open-ended pipe piles, or piles, I should say. But you tell us a little bit more about the research and the outcome and how it all went.
Sure. So in a large diameter open-end pile, so as I said earlier, these are piles, in our project, we define them as anything greater than 30-inch diameter.
Okay.
They're increasingly being used in transportation infrastructure projects. Obviously, they're of interest, they have high load carrying capacity, they can sustain high lateral loads, significant flexural resistance. But, in seismic areas like this, they can still have some flexibility. They can have a substantial unsupported length, when you've got scour conditions, marine
Mhm.
conditions, or significant liquefaction. Um, and however, there's significant uncertainty associated with large diameter open end piles. It's in part that they're open-ended. Well, actually backing up, there's a lot of existing piles out there and a lot of existing static design methods, and the majority of those static design methods, were developed quite a while ago
Yeah.
there was a lot of load testing done, it seems like in the 70s and 80s, all on smaller diameter foundations.
Hmm.
And foundations have continued to increase in size, but it seems like there was a period when load testing stopped.
Wow.
And so these old design methods didn't really, or have questionable applicability to larger diameter foundations. Some, for example, like the Nordland method for piles, is known to over predict the pile resistance,
Hmm.
and is therefore, really not preferred to use.
Yeah.
So there's that question. And then also, a lot of the existing static design methods just don't address pile plugging.
Hmm.
An
Yeah.
open end pile, right? We have, resistance acting on the pile exterior. And at the base, a plug can form. And if
Mhm.
so, you've got end bearing acting over that full, end area. Or, the pile may just core through the soil. And in that case, you would have base resistance just acting on the steel annulus
Mhm.
and potentially side friction acting on the pile interior. The magnitude of that side resistance on the pile interior is, in some projects, it's been known to be very small, and
Mhm.
in other cases, it's been more significant.
Wow.
And so, you know, this whole like fundamental nature of open-end piles is really not very well understood and
Yeah.
certainly not captured in the design guidance. So, you know, Shannon Wilson, my firm, and I, you know, we had a lot of experience using large diameter open-end piles prior to this RFP coming out.
Mhm.
We'd driven some of the, you know, for the EB Slough Bridge here in Washington, you know, at the time it was the largest diameter piles. They were 6-footers that the state had ever driven. You know, we supplemented that by an extensive dynamic test program. Up on another project, this Portman Bridge,
Mhm.
we had, you know, it was a cable stay bridge with the north and south pylons supported on these huge pile groups. I think they were 49 and 63 groups of 49 and 63 piles, all
Okay.
6-foot diameter at the north and south
Wow.
pylons. I mean, these are
It's
huge
massive.
caps. And so
Yeah.
we did, you know, this big load test program and tested a 6-foot diameter pile to over 12,000 kips and moved
Wow.
it almost 6 inches. So, you know,
Okay.
really cool stuff that we had seen, you know, and been a part of with large diameter open-end pilots and had really understood, you know, where some of this uncertainty is. And and for the research, we teamed with Dr. Mike McVeigh at the University of Florida and his group, because large diameter open-end piles, it encompasses not only the steel piles, but concrete cylinder piles as well,
Okay.
where he had a lot of experience and then also experience in resistance factor calibration. With the research, you know, we collected a huge mass of existing load test data and built a load test database. I think we collected over 160 load tests on large diameter piles, created this database to house them. And with that, you know, FHWA had a previous deep foundation load test database, and we extracted all that data and populated it into our new database. And, you know, for all the listeners, that database is out there and available for free download. You can find it just by Googling FHWA Deep Foundation database, load test database, and it
Excellent.
should get you there. But you know, we collected this data, built the database, and then we used the data to, you know, evaluate existing static design methods. And with the research and the data that was collected, we really weren't able to, you know, look at, you know, the fundamental mechanisms of piles plugging or not. It would take, you know, an infinite amount of load test data in,
Yeah.
you know, of all kinds of sizes and all kinds of conditions, I think,
Yeah.
to really understand that. And so our goal was to, you know, I think bracket the problem and develop, you know, usable guidance for design of large diameter open-end piles. So with this, we evaluated existing design methods, tried them in different combinations, looked at which methods were more and less effective, and then developed resistance factors for, you know, that are specific to large diameter piles. You know, we wrote all the research that's summarized in an FHWA research report. And since that time, we've been um, working to get the recommendations implemented into the AASHTO code.
Awesome.
And so then they can, you know, be used in design.
That's
So,
great.
you know, it's really been a tremendous experience. And I think as a practitioner, it's really a cool opportunity to get to build on one's experience and apply it to research on something that, you know, is something that you use in your practice and, you
Exactly.
know, to really help to get to shape the practice. So yeah, it was a really cool opportunity.
That's awesome. And I think that anytime that you have, you know, practitioners working alongside the research and the agency side, when they're all working together, you're going to end up with something that we're using, which is pretty exciting, you
Yeah.
know?
Yeah. Yep. And something that, is usable.
Yeah.
Yeah.
Now, when we talk about large diameter open-ended piles, are you seeing that like just select areas in the world or select areas in the country are using this system, or you kind of see it everywhere?
You know, that's a good question. For a long time, large diameter open end piles were, you know, well, they have been used in the offshore industry for several decades. And that, I think, is where their use was concentrated up until the last 15 or 20 years. And since that time, we've been seeing them used more in transportation infrastructure projects. We're using them here in the Pacific Northwest. There's been numerous projects in California. Caltrans has actually done a lot of load testing on their large diameter open end piles. There's several, projects, from, this load test data collection effort. We had load tests around the country that we input into that database, and from around the world. And so I think, yeah, we see them being used everywhere where the need arises.
Love it. Love it. Love it. That's great. Largest diameter pile job you've worked on? You don't have to say the job, but largest diameter?
For the piles, me personally is just the 6 foot on large diameter piles. My firm, we currently have a project with 7 footers that, I've just been
on the periphery.
The exciting parts of. Yeah. So, I would say, shafts, we're certainly seeing bigger diameters than that, as I mentioned, 12-foot diameters.
It's
increasingly
whenever you start to think about, for me personally, whenever you start thinking about these diameters, you start to automatically think about the machine that has to install it. Like everything gets scaled up, right?
Yeah. And it's nonlinear.
It's nonlinear, exactly.
Yeah.
Awesome. Well, before we take our break, advice that you would give listeners that want to pursue a similar career to yours. Again, you're a practitioner with a PhD. And you're doing some really cool things. Advice?
I have really loved being at my firm, Shannon Wilson, because of the incredible breadth and depth of technical expertise that we have, and this huge array of projects and project types that we work on. And, engineering is a very experience-based field, right? And I think, with each project that we work on, we learn something new. And it's like, another tool in the toolbox with every project we work on. And so I think, having the opportunity to work on, a wide variety of projects, really it helps put more tools in our toolbox, and being able to have some kind of specialization and go deep on things, it's sharpening those tools. But there's that, and then the colleagues, having great colleagues to seek out for, input or advice or troubleshooting, it's like being able to dip into their toolboxes too. And so I would really say for, people, at the start of their careers, or, anywhere you're at, to really seek out projects and people and opportunities to help you grow, to continue learning, and discover new things. I think that's so much about what it's about. It helps to make us better engineers and leads to better outcomes overall.
Love it. Thank you so much. So we're going to pause right here. I'm going to come back in just a moment and close this one out with Dr. Kathryn Petek and our Career Factor Safety End segment. Stick around. All right, welcome back. It's time for our Career Factor of Safety End segment. In geotechnical engineering, just like many disciplines of engineering, it's important to incorporate a factor of safety into your design. But one could ask, what about incorporating a factor of safety into your career? Today, of course, we're speaking with Dr. Kathryn Petek. Kathryn, you've had a very successful career. And when you look back at your career, what's one thing you implemented to give yourself, let's say, a factor of safety in your career?
That's a tough one, Jared. A factor of safety. So this means, right, something that gives you excess capacity to meet the demands. And I would say that one of the really key things for me has been about building relationships.
Okay.
In that, you know, it probably goes for life in general, that I really think relationships are, one of the fundamental keys to success. And I see this in, building relationships with my superiors. It's great to be able to talk to the boss and say, I've got this issue and I could use some support, or here, I've got this idea. What do you think? Or, people who have been mentors, and leaders um, for guidance, and those who have helped me with opportunities along the way. There's relationships with my peers, that it's good to have friends at work.
Yeah.
It's good to have colleagues who you can call up and ask a stupid question and not feel stupid.
Yeah.
Or just be able to brainstorm together, or share successes or disappointments. And relationships with, younger staff, that, there's a really critical transfer of knowledge, I think, that's going on. I think that we learn a lot in mentoring relationships, both being a mentee and being a mentor. And frankly, I really love the perspective that young people provide, that I'm not even that old, and yet,
Right.
and yet there's something different, right? That's really exciting.
Yeah.
And I think also, with clients, that, it's all about relationship building, that, with stronger relationships, we can collaborate more and better. Having good relationships helps us, with securing more work, or continuing together, or looking down the road. And and so I guess also competitors, that, there's a lot we can learn from each other, when we're paying attention. And there's even opportunities where with competitors we can collaborate and build on each other's strengths.
Yep.
So, I would just say that relationships are, extremely important and have helped me so much in my career. And I think really help to build in that extra capacity, to meet the demands.
Excellent. Excellent. Thank you so much. Thank you so much, Kathryn. I appreciate you coming on and sharing all the insights you did with us. And you shared great information and advice that I know is going to help our listeners. If a listener is listening and saying, man, how can I reach out to her? What's the best way for people to find you? You want to share your email, or if you're on social media?
Sure, you can. Probably easiest is at my email. I'm not that old. I said that, but I'm really bad at social media.
It's all
So
right.
email me. My initials, KAP@shanwill.com, or I think you can also reach me at Kathryn Petek at shanwill.com.
Excellent. Excellent. Thank you so much for coming on. This is great.
Thank you.
I hope you enjoyed the episode today. We would love to hear your feedback, comments, and/or questions. Please feel free to go to geotechnicalengineeringpodcast.com, where you'll find a summary of the key points discussed in today's episode, that being episode 27, as well as any of the links, resources, websites, and books mentioned during today's episode. Until next time, we wish you the very best in all your geotechnical engineering endeavors. Peace.